All right, hello people watching this video. We are doing the second half of 3-1 notes that we started yesterday. We went through mean, median, mode, and range, or mid-range, excuse me, not regular range, mid-range. And we're going to finish this today. The next couple days, I'll just give them time to work in class because Lawrence, you guys are gone. Monday, though, we will start 3-2 notes. So look for a video then. But this is the last video I'm going to send you for the week. Monday we'll do another one on 3-2. Okay? So mid-range is where we ended. I'm going to go through just a little bit about mid-range again, just because that one's the only one that we haven't probably done before. And I said the mid-range is what the median number should be, not what it is. Like when you're looking at your data sets, the median is the middle number, right? But that doesn't necessarily mean that it's in the middle of your data set. So I said these numbers. Somebody have my pen.
Here.
No, my pen.
Oh, sorry. I'm trying to
My pen.
I apologize. I don't
Where
have
is it? Where? Grab it.
There,
Where?
underneath Tanner.
Oh, I see it.
James.
Where?
Oh,
you put it there.
Right above. Tanner.
Reach right there. Yeah.
I can't. Okay.
Who's that?
Okay.
Get on my way for it.
That's my, okay, whatever. Okay, so what the middle number should be. So if I have a data set that is 1, 2, 3, 4, 5, and 53, my middle number is 3.5. That is the median, right? It's exactly in the middle. There's 6 numbers, so I have to average the 3 and the 4. But if I go and do what the middle number should be, because I have that 53 all the way outside of there, we add these two together. It's like finding the average. 1 plus 53 is 54, and divided by 2, the middle number should be 27. That's what the mid-range is, okay? So my median should be 27, even though it's only 3.5. That's how you do the mid-range, okay? You add them up and divide by 2. All right, let's go down to this one, example 6. So flip over to the next page. They are talking about when it is not meaningful, circle the words not meaningful, to do the mean and the median, okay? In these scenarios, it does not do a darn bit of good for me to find the mean and the median. You will have some examples like this on your homework assignment, okay? Where they say, what does this information tell us? Well, it doesn't tell us diddly squat because I don't care what the average jersey number is, right? Like we wouldn't mean anything to average jersey numbers together because that doesn't tell you anything, right? So here, when we talk about zip codes and we find the average zip code, what would the average zip code tell you? Nothing. Right? Zip codes are more categorical data, right? These are categories. Zip codes are more of categories, so it doesn't do anything for me to average them or to find the middle number or whatever for a zip code. Same thing with ranks of selected national universities like Harvard, Yale, Duke, Dartmouth, any of those. Those are all categories. Now, within the categories, if they have rank, do you remember what the classification underneath of categorical data was? Where it has a rank. What is it called if it has a rank? Ordinal. This is ordinal data. Okay, ordinal data, but still it is a category, so it doesn't do a darn bit of good for me to do a mean or a median with that stuff. Okay? Now I could do a mode. Maybe. Like if I was doing zip codes, I could maybe do a mode to see which town is the most prevalent in a data set or whatever, to see which zip code pops up the most. But for mean and median, not meaningful because it's not quantitative data, okay? Part C is the number on jerseys, okay? Why is that not meaningful?
Because it skips around. It's random.
Well, because it skips around also, but it is another category. Like categorical data, even though they're numbers, jersey numbers are categories, so it doesn't do me a darn bit of good. If I say the average jersey number is a 53.7, that doesn't do anything for me, okay? I'm going to underline this part. The numbers on jerseys don't measure or count anything. They are just substitutes for names. They're categories, okay? Part D, number 5, or excuse me, top 5. Top 5 incomes of CEOs. Okay, now this is important. This is a good one. The top 5 incomes of CEOs are 131.2, 66.7. These are all in millions of dollars, okay? Now, this is quantitative data. This is quantitative data, but why is it not probably meaningful for me to find the mean or the median, the average of those top 5 or the median of the top 5. Why would it not be probably a good thing? Like I could, and it would maybe tell me something because that's quantitative data, but why is that not helpful?
Because they're so different.
The top 5 are not at all representative of the larger population. That's just the top 5. That doesn't really tell me a whole lot other than the top 5. I can't use that to then interpret anything about a population of everybody, right? Because the top 5 are not going to have the same income as everybody else, right?
You could interpret like the top
So,
5 of each.
Right. So it's not as useful to do it that way. Does that make sense? So I could find the median and just say the mean of the top 5 is this, but as far as it goes to like relating it to an entire population, which is what we usually do to try to interpret things, it is not going to be as useful. So top 5 is not at all representative of the larger population. Circle that or underline that. Not representative of a larger population. That's why you would not want to rely too heavily on the mean or the median, okay? And then the last one, the 50 mean ages computed from the means in each of the 50 states. If you calculate the mean of those 50 values, okay. So what they're saying is they're taking the ages. Okay, let me explain this to you. So we have Nebraska, and we have Kansas, and we have Texas, and we have California, and they take the average age of people in Nebraska, and then they have the average age of people in Kansas, and then they have the average age of people in Texas, and then they have the average age of people in California, and then they average all of those together and they get one number. Okay? Why would that not be a good thing?
Because it doesn't tell
Nebraska
you.
has younger folks. California is more retired.
You think Nebraska's younger folks?
Oh yeah.
I'm
Why?
just thinking.
Because no one's gonna retire here.
No.
Nobody's gonna retire. Okay, I get that. I like that idea.
We won't have super old people, but we won't have super
Yes,
young
ma'am.
people.
Yeah, that's the deal. So proportionally, they're not represented, right? There's more people in California than there are in Nebraska,
Absolutely.
right?
But it
So
also-
proportionally, they're not going to be here. They're going to be represented equally because we're doing the average and then we're averaging all of them together, right? Okay. So we have to take that into consideration. We would probably just need to average all of the people total, right? Like total people everywhere, okay? Rather than average of each state and then average those, okay? So we need to take into consideration the proportion of people, right? And I get what you said, Kyle, about like in Nebraska, you're probably not going to have as many older people just because they're not going to retire in Nebraska, right? Okay, a lot of people go to like retire at a vacation home in California or in Hawaii or in, Texas or Arizona or wherever, right? So that is going to push those ages up as an average, right? Where it's going to bring Nebraska down for an average age, okay? So you need to take proportions
And it was
into consideration.
matched it to
What shirts are you making?
They say the population sizes of the 50 different states must be taken into account, so the proportions need to be correct. Got it?
That's funny.
It's Good?
Terrible.
What shirts are you making?
All right.
I mean, doing that in your head in 50 seconds.
The backs of the sponsors.
Again?
All right. Yeah.
Still?
And then I get back and Libby looks at me and
'Kay.
she goes, "Oh, look, the crazy kid's back." I remember that.
All right. Now, one of the last things. Are you listening? Oh, we got two things. Two things left. Frequency distribution. Here is the next thing. Example 7. We got 2 examples left. Here we go. Not very much. Shh. Frequency distribution. If they give me a frequency distribution like this stuff, and they say find the average time that it takes. I just want one number. I want to find the mean. Okay. I know that there are 11 orders that came in 75 to 124 seconds, right? I know there was 24 orders that came in here. There was 2 orders that took a really, really long time. I want to know the one number that gives me the average. How do I find that? The problem with the frequency table is that I know there's 11 numbers in here, but I don't know what those exact numbers are. If I knew the exact numbers, I could just do that all together, right? But how do I find the average if I don't have those exact numbers?
Would you use the middle?
Class midpoint, right? That's the next thing they did. So 75 to 124 to find the midpoint. If you don't know how to do that, 75 plus 124, you divide it by 2, and that gives you 99.5, okay? Now, I know that there's 11 numbers that we're going to say are approximately 99.5 because we're just going to go by the middle, right? So there are 11 of those numbers. If I multiply 11 times 99.5, I get this guy. That's what they said, F times X, right? If I do that, then I take 24 times 149.5 because that's the midpoint of that, right? And I get this number. And I multiply these together, these two columns, and then I add these all together, and that is this number. And then what?
Divide by 1, 2, 3, 4, 5. 50.
Divide by
50.
50, because there's 50 numbers. Okay, somebody do that real quick for me, because I don't have the answer. What is 8025 divided by 50?
400.
160 and a half.
160.5.
Way off.
Okay, and that is in seconds, right? So 160.5 seconds is the average amount of time that it takes. So somewhere in this category right here. Okay, 160.5 seconds lives in this category. Now, why would it live in that category?
Because it has the most frequency.
It has the highest frequency, right? So it's probably going to fall in that range, right? Okay, so I mean, not always will it do that, but since that's the highest frequency, it's going to be like pulled toward that category. So 160.5. So let me review that, okay? We don't know what each one of these individual 11 numbers are, so we just take the midpoint of this class and take that and multiply. There are 11 numbers that are about 99.5, so we take that and multiply. And we do that the same for each class midpoint, add those together, and then we divide by the total number of people that we gathered data from, or what our N is, which is 50. And divide, and we get 160.5. Okay, questions about that? That's how you do a frequency distribution. You have one like that on your homework. I know for sure.
Perfect.
Perfect. Okay, the last one is talking about a weighted mean. A weighted mean. You guys have like weighted averages. So let's say for homework and for tests and for, you guys have projects in this class. Okay, so we have homework, test, project. Okay. Homework, you have a bunch of homework grades, and let's say you have 4 homework grades. They are a 90 and a 94 and a 92 and a 99. Okay, I should have made something that comes out really nice. You have 2 tests, and they were an 88 and a 95. I don't know. We'll go 96, 88, 96, because then I can average those in my head. Okay, and then you have 2 projects, and they were a 100 and a 98.
You read that on 76.
What?
76.
No. It's fine. Okay. So out of your homework grades, what's the average homework grade? If you add those all up together and divide by 4, what do you get for an average? Somebody want to do that for me? Okay. What's your average test grade? If I have an 88 and a 96, what's the average of those two numbers?
92.
90.
1. 92.
92. 92 is the average of those two. Okay. What's the average of 198? 99, right? What's the average of the top one?
93 and 3/4.
93.75?
Yep.
Okay, so out of all those, I have 4 homework grades. My average homework grade is this guy. 2 test grades. My average test grade is this guy. 2 projects. My average average project grade is that guy. Okay. Now, homework is worth 25% of your grade. Projects are worth 25% of your grade. Tests are worth 50% of your grade. So now, how do I take the overall and find the overall average? This is a weighted average.
Hey, I think it's supposed to be with them.
Yep. How do I find the overall average?
Multiply them by the percentage and then add them up.
93.75 is weighted at 25% or 0.25, right? Plus 92 is weighted at 50%, which is 0.5. Plus your 99, your project grade, is weighted at 25%. Now, what do you divide by?
3.
No, 1, 2, 3, 4, 5, 6, 7, 8.
No.
Think.
What do all my weights added up to be? Like this is 25%, 50%,
100%. So 1.
25%. So I divide by 100%, which as a decimal is
1.
1. So you really don't have to divide by anything. Does that make sense?
Yeah.
So in the average, I always think like you're averaging things together, you're adding stuff together, and then you still have to divide by something. Well, you're dividing by 1, you're dividing by 100%, okay? So if you do that, did somebody get an answer for me?
94.
You got a 94 point?
0.19.
0.19, 94.19. That's how you find your average, right? Okay? So that is exactly what PowerSchool does for you. Exactly. PowerSchool does that exact thing. Okay? It has your class weights and everything, and then it averages each of the categories together. It averages those, then it weights them. Okay? That's exactly what PowerSchool does for you. So you have a 94.19. Great. Awesome. Okay, let's go to this question. This is computing grade point average. So now we're talking not grades like we have percentage grades. They're talking like credit hour grades. So this would be like on the college level, this type of thing. Okay, so it said her final grades along with the number of credits for each course were an A. She got an A in a 3 credit. I'm writing these down just in a list. Okay, you see where I'm at?
Credits for different.
A was 3 credits.
Yep.
A was in 4 credits.
I thought it was just like credits or hours.
No, the credits are predetermined. Like this credit, this stats class, you get 3 credit hours for. Okay. Credits are based upon like how much time you'll spend in that class. So if you usually have a class 3 days a week, it'll be worth 3 credits. Sometimes you'll have like a freshman level class where you only meet once a week. It's kind of like a check-in class, or like how are you doing type of thing. And you only meet once a week. That'll be like 1 credit hour. If you have a lab, like let's say you're in biology that has a lab, usually that'll be 4 credit hours, or anything with a lab. Like I had calculus with a lab, or chemistry with a lab, that'll be 4 credit hours. Okay, so the credits are predetermined, and then your grade is obviously up to you. Okay, so A in a 3 credit hour course, A in a 4 credit, B in a 3 credit,
For you?
C in a 3 credit. And then you got an F and a 1 credit because we didn't care about that 1 day a week class that we had to go to, evidently. Okay, so this is what happens, right? Now, when we're finding average, we usually try to multiply those together. But how do you take A times 3? Like 1 is a
You give it
number and 1's a variable.
quantitative.
Yeah. So what we do is we say, okay, an A is worth 4, right? You see what they've done here? An A is worth 4. So instead of doing A, we're going to multiply by 4, right? Instead of doing B, so this is this is a 4, this is a 4. A B is worth 3, so we're going to multiply by 3. A C is worth 2. We don't have any D's, but then an F is worth 0, okay? Got it? If I multiply those together, all right, I should put my multiply, okay? For that first class that I got an A in, I got 12, points, basically. I got 12 points. What about in the second class?
16.
16 points. How many did you get in the third class?
9.
9 points. And then
6.
6 points, and then
0.
0 points. So I got absolutely 0 points for getting an F in a 1 credit hour class. I got 0 points, right? When I could have gotten a maximum of 4 points, right? That could have added 4 points to my thing if I got an A, right? Okay, so I got that. Now what do you do with those numbers?
Add them up.
Add them up. 12 plus 16, that's 28, 37, 43. I have no idea.
Yes.
Yeah, okay. 43. All right, now, this is the biggest problem. This is the biggest problem. 43. We have to divide by, okay? Which one do you divide by? Do you divide by these numbers added together or these numbers added together?
Second one.
The number of classes.
No, the 3 plus the 4 plus the 3 plus the 2 plus the 1. That's per credit.
Okay, here's what I ask. If you were a student that got different grades in another class, like in these same classes, you would divide by the same number. You would divide by the credit hours,
14.
right? Does that make sense? You would divide by the credits, right? I don't care what your grades are. You divide by the number of credits. So that another student would divide by the same number, right? They would divide by just the credit hours. How many credit hours are we taking?
14.
14, if you add all those together? That's not right. What? 3, 6, 9,
9, 10,
14.
14. Okay, you're right. Okay, I can't math. I was just trying to mental math. 43 divided by 14.
307.
3.07 is what we get. Okay, so do you understand why it's credit hour you divide by? If I had somebody that got all F's, right? Okay, I would get 0, 0, 0, 0, 0. You're not just going to divide by 0, right? That'd be awesome. Well, or just divide by 1, right? Let's say I got an F and then my last one was a D, right? Then I would have 1 over here and I would divide by 1. So you tell me I got a 43 in the class? That's not going to work out, right?
No.
So you
because
always
get
divide by
one-
credits.
You wouldn't get the 12 and the 16 and the 6 though. You'd be 0, 0, 0, 0.
Right, true, I guess. Yeah, whatever.
1. You'd get a D. It'd
Sure.
tell you exactly
Yeah,
what you got.
yeah, I mean, kind of, yeah. So you want to divide by credit hours.
That's okay.
Maybe put a star. Divide. I can't spell. DIVIDE by credit hours. Okay, you want to make it consistent through all the kids. So if another kid had the same schedule, you would divide by the credit hours, not what they got in the class. Okay. All right. If we divide by 14, 3.07. What did they get? Did they get an A, a B, or C, or a D?
B.
They got like a B minus probably, right? Because they were just right above a 3. Yeah, they got like a
B plus. They got above a 3.
yeah. So an A would technically go. So they got an A minus basically. Maybe
Or B plus.
or a B plus.
How do A minus would probably be closer to like.
Right, like if we're doing a 4-point scale, right? If we're doing a 4-point scale, an A would go from 3 to 4, right? A B would go from 2 to 3. A C would go from,
1 to 2.
but then that wouldn't work with F's. How does that work?
Start at F and
I don't know. We'll say that he got a B because I think it's gonna go by like
Close
what
enough.
category it's in. So he got a B.
Yeah, I can use it.
Okay. Yeah, because B is in the 3 category. So I think you have to get like a 4. A lot of people say like some people get like a 4.2 out of a 4 grade point average because they'll take like advanced placement classes. We talked about this last year when we did
Yeah, that
trade.
is
Okay.
correct.
So if you take AP classes, a lot of times they'll let you get over a 4.0 instead of just a 4.0. Like that's not the cap. Like it goes like up to 5 points if you're taking advanced placement or college credits. So there you go. B is 3.07. We'll just say that. They only wanted the 3.07, but I'm just relating that back to B. Okay? Questions about that? That is calculating weighted average 2 different ways. So if you're given the actual like 90% whatever, or if you're given credits, that's how you divide. Got it? Okay? All right, you should be able to do all the rest of these. This is number 30 is going to be one of those frequency tables. Okay? Where you find the midpoint and you do the things and you get the average, right? Okay? So there you go. That's all I have. Some of these take a bit of time, so I would not wait to do all of them. All right? Okay. Goodbye, people.
As I get